Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concept of vectors in R3. So as per the problem, if vector m is equal to 2i minus k, vector n is equal to negative 2i plus j plus 2k, calculate each of the following. Now in this vector m, there is no j unit vector. So that means the coefficient of the j unit vector is 0. So we can rewrite this given vector m as, so this will make it easy to solve the problem. Now we can start with part A. So in part A, we have to find the magnitude of vector m minus vector n. So first we will find the difference of vectors m and n. Now we can get rid of the parentheses around the second vector by distributing the negative 1 in the parentheses. So basically we are doing scalar multiplication. So we'll multiply the coefficients of I, j and k by negative 1. Now we can combine the I, j and k unit vectors. So for the I terms we have to do 2 plus 2, which is equal to 4. And for j terms we have to do 0 minus 1, which is equal to negative 1. And for k, we have to do negative 1 minus 2, which is equal to negative 3. Now we do not write 1 as a coefficient. So in the next step, we can rewrite this vector as, so this is the vector for m minus n. And now we can find its magnitude. So for that, we'll square the coefficients of I, j and k, add the squares, and apply square root to the sum. Now we can square the terms. So negative 1 square is equal to 1 and negative 3 square is equal to positive 9. And when we add these numbers, we get 26. And square root of 26 is equal to almost 5.1. So this should be the final answer for part A. Now we can analyze part B. In part B, we have to find the magnitude of m plus n. So first we'll find the sum of m and n vectors. Now we can add the I, j and k terms. So for the I terms, we have to do 2 plus negative 2, which is equal to 0. For j terms, we have to do 0 plus 1, which is equal to 1. And for k terms, we have to do negative 1 plus 2, which is equal to positive 1. Now we do not have to show 1 as a coefficient, so we can rewrite this vector as, so this is the sum of vectors m and n, and now we can find the magnitude. So we have to square the coefficients, add the squares, and apply the square root. So I got square root of 2, which is equal to almost 1.4. So this should be the final answer for part B. Now we can analyze part C. So in part C, we first have to find the equivalent vector for 2 times vector m plus 3 times vector n. So we'll replace m and n by the given vectors. Now we can do the scalar multiplication. So we'll multiply the coefficients in the first vector by 2. And we'll multiply the coefficients in the second vector by 3. Now we can combine the I, j and k terms. So for I terms, we have to do 4 minus 6, which is equal to negative 2. For j terms, we have to do 0 plus 3, which is equal to 3. And for k terms, we have to do negative 2 plus 6, which is equal to positive 4. Now we can find the magnitude of this vector. The negative 2 square is equal to 4, 3 square is 9, 4 square is 16, and if we add these numbers, we get 29. And square root of 29 is equal to almost 5.4. So this should be the final answer for part C. So now we can analyze part D. In part D, we have to first find the vector minus 5m. So we'll multiply vector m by negative 5. Now we can do the scalar multiplication. So we'll multiply each coefficient by negative 5. So this is the vector that represents negative 5m. Now we can find its magnitude. The negative 10 square is 100. and square root of 125 is equal to almost 11.2. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.